Here we have a SAT math problem. Okay, let's go to the question. Which system of linear equations has no solution? Okay, in the given answer choices, we have to find the system which has no solution. And in each answer choice, we have a system of two linear equations in standard form. Standard form means we have x term and y term on one side of the equation and the constant on the other side of the equation. Okay, now let me consider a system of two linear equations in standard form, that is ax positive by equals to c1, and the other one is ax positive by equals to c2. Here we have a system of two linear equations in standard form. Okay, when I consider the coefficient of x in the first equation and coefficient of x in the second equation, they are same. And the coefficient of y in the first equation, the coefficient of y in the second equation is same, that is b. But the constant term in the first equation, constant term in the second equation are different, c1 and c2. Okay, when we have two linear equations in standard form with the same coefficient of x and same coefficient of y and different constant terms, then the system of these two linear equations has no solution. Okay, now we have to check this stuff with each system in the given answer choices and find the system of linear equations which has no solution. Okay, now let me consider the first one, that is in answer choice A. Okay, in answer choice A, in the first equation, the coefficient of x is -3. In the second one, the coefficient of x is 3. Okay, our first aim is to get the same coefficient for x. Okay, now to get the same coefficient for x in both the equations, let's multiply the first equation by -1. That is, each term of the first equation has to be multiplied by -1. When I multiply this one by -1, I am getting 3x. When I multiply this one by -1, I am getting -7y. And when I multiply this -9 by -1, I am getting +9. Okay, now we can take this equation as it is, that is 3x -7y equals to 9. Okay, here we have the same coefficient for x and same coefficient for y and same constant term. But according to the stuff we have discussed over here, the constant terms must be different, so that the system will have no solution. So the system in answer choice A does not meet the stuff what we have discussed over here. So we can reject answer choice A. Okay, now let me erase this stuff. Okay, let's reject answer choice A. Now let me consider the system we have in answer choice B. The coefficient of x in the first equation is 3. The coefficient of x in the second equation is 2. Okay, now let's try to make the coefficient in both the equations are same. For that, we have to get the least common multiple of 3 and 2, that is 6. So that is, we have to make the coefficient over here as 6 and here also 6. Let's multiply the first equation by 2 to get 6 as the coefficient of x. Okay, let's multiply each term of the first equation by 2. 2 times 3x is 6x, and 2 times -7y is -14y, and 2 times 5 is 10. Okay, now let me multiply each term of the second equation by 3 to get the same 6x. That is 3 times 2x is 6x, and 3 times a positive 8y is a positive 24y, and 3 times 6 is 18. Okay, here I got the same coefficient of x, but I don't have the same coefficient of y. So the system in answer choice B does not meet the stuff we have discussed over here. So we can reject the answer choice B. Okay, let me reject this one. Now let's consider the system in answer choice C. In the first equation, the coefficient of x is 4. In the second one, the coefficient is -12. Okay, now let's make this 4 as -12. For that, we have to multiply each term of the first equation by -3. Okay, now let me do it. -3 times 4x is -12x, and -3 times -9y is positive 27y equals to -3 times 7 is -21. We can take the second equation as it is, that is -12x positive 27y equals to -21. Okay, here we have the same coefficient for x and same coefficient for y and same constant term. The same thing what we have discussed for answer choice A. So according to the stuff, the constant terms must be different. But here the constant terms are same. So the system we have in answer choice C does not meet the stuff we have discussed over here. So we can reject answer choice C. Okay, now let's consider the system in answer choice D. Okay, here the coefficient of x is -3 and here the coefficient of x is 6. Now to make this one as 6, let's multiply each term of the first equation by -2. Okay, when I multiply this -3x by -2, I am getting positive 6x. And when I multiply this positive 8y by -2, I am getting -16y. And when I multiply this 20 by -2, I am getting -40. Let me write the second equation as it is, that is 6x and -16y equals to 40. Okay, here we have the same coefficient for x and same coefficient for y and different constant terms. Okay, the system in answer choice D meets the stuff for what we have discussed over here. So in the given answer choices, the system of two linear equations in answer choice D has no solution. So the correct answer choice for this question is D.